Hello, everyone. My name is Liviu Dudau. There's a small change in the schedule. I swapped places with the presenter that was supposed to have this slot. So I'm going to talk about IOU ring for DRM. My hope is that I'm going to be very controversial because I only have like 11 slides. So hopefully there's going to be a lot of discussions. So first about me, I've been working on upstream Linux kernel for about 10, 11 years. At some moment, I moved into graphics, started doing the display driver for ARM, maintained that for about 8 years. I'm now involved with the Panther driver. Had a small hand into the naming at some moment. I maintain the Mali firmware binaries for CSF GPUs on Linux firmware. So if you want firmware for your GPUs, come and talk to me. And one of my official jobs at ARM is to interface with the community. So talk with you guys and be on the mailing list and on IRC. So I'm on the Panfrost channel, I'm on the DRI Devel IRC channel under the Liviu name. And it's my second Montreal XDC. So welcome to all the people that been here before. So what I'm trying to solve. I started by working on the user mode submission for Panther. And by some happening, I also started as I wanted to read on the AMD previous user mode submission. And then reading about IOU ring, and it's like, oh, there's a lot of similarity. I wonder if it would be a good idea to have IOU ring in DRM. Why? Because a lot of the modern GPUs now want to submit jobs from user space. They don't want to pay the cost of context switching into the GPU just for the submission to happen. When you use the open source stack, Mesa, at least on the Gallium side, on GL, strongly assumes that you are going to send your job to the kernel. We've been trying to patch Gallium, at least for Panther. It's an ugly hack. So we don't want to even go there and maintain it. Vulkan is a bit better in Mesa. And with Vulkan, you really want to do it in user space for quite a lot of jobs. And you can get performance. There are different numbers being floated around from 3% to more than 30% on some different tests. I still don't have a definitive answer what's the main gain, but everyone I'm talking to is like, no, we want user space to do the job submission. And trying to synchronize between user space, kernel, and firmware or hardware, it's not that easy. So what I was thinking about, what if we can have kernel mode submission and still have user space submitting jobs, and we still don't pay the context switch cost by using IOU ring, right? There's already a mechanism that exists for doing asynchronous submissions from user space. You can still be in charge in the user space on creating the jobs and preparing everything. You just pass it on to the submission queue. And you leave the kernel to do the low-level work, right? The kernel driver still is the one that programs the register, still submits the job, gets the interrupts, responds, puts the result in the completion queue. So it should offer some of the benefits and apparently a lot of the drawbacks of having user space submitting stuff into the hardware. But you could already do that, right, with shaders, and it's not that much of a change. Why IOU ring? Again, I kind of explain a bit. Hopefully less context switch costs. I have this crazy idea that you could actually do like a just-in-time optimization of your job submission. If you have like a hot path, you can switch to using IO ring and submit your jobs. Otherwise, you can just send to the kernel via normal ioctls. Probably crazy. I don't know. I'm trying to be controversial again, so get people to react. And for most of the hardware, the submission stays the same as it is. So if we put IO ring in the framework, then all the drivers get UseMO submission for free, technically. So quick recap on the IO ring. You have a submission queue where basically userspace adds jobs, and you have the option to either for each insertion of the job to get the kernel to do it, something, and you can wait for, or you can do a number of submissions, and you could say, I want on this submission to wait for X results, or a number of results to happen. Or you can wake up a K thread to do the work for you. And the K thread will put the results on the completion queue, and they're out of order. So you can complete stuff whenever so you can parallelize jobs. Userspace basically reads the completion results and flushes out the jobs that finished. I don't know why the screen is cutting down. But basically what the bottom thing says is not very different from what AMD has proposed in their RFC a couple of years ago for UseMO submission. They had the completion queue, they had the submission queue, so it's not a new idea. So what am I proposing? Adding IO ring support in the DRM framework. We basically going to have the user space creating queues and submitting, and then K-thread basically goes and talks with the driver, and it hands over the job. And basically the IO ring job is just a wrapper around the GPU job. So hopefully 0 copies. I haven't, compared to other talks, I don't have a demo. I haven't even started to write any of the code because I want to know if people think I'm crazy or I should basically stop right now, or they might think it's a good idea. So the result is we still have the same submission path in the kernel side. It's just we decouple the user space from having to wait and having to pay context switch costs. We might need to understand on the framework level some specifics about the jobs of each of the GPUs, which might break the whole layering in DRM. So that's one of the downsides of that. Or you can have an abstraction layer for GPU jobs that each driver implements. Don't know if people have any thoughts about that. And at the moment, you can make, through IO ring, you can make all sorts of requests. So you could basically pass an FD that is a network socket. And you can have technically a GPU that renders to a network socket. So you send your buffer to over the net. So VNC, accelerated VNC. Technically, I think you can pull it out if you really want it. I think you can pull it. But I think we should also try to introduce some filters for some of the ops that we going to accept or not accept. And one of the reasons is that Chrome OS last year announced that they spent about $1 million paying bounties on bugs related to IO ring. So they decided to disable it completely on Chrome OS and disable it for apps on Android. Bugs were fixed pretty quickly. Doesn't mean they fixed all of them, and there's still no bugs. I think for Android, they have a BPF filter that could validate some of the policies for job submissions. But I'm pretty sure nothing exists for box under Linux. So security is going to be a big problem to solve. One of the solutions is that, okay, we don't actually use IOU-ring, but we create a IOU-ring-like solution for DRM that is specific just to DRM, and we just have jobs for DRM in there. And I have no idea how DRM scheduler is going to play with this thing. Is it going to be mapped one-to-one, one-to-n, none at all? So I'm asking for feedback and for people to say if they think it's a bad idea and I should stop and do something else more productive.
You want feedback now?
Yeah, yeah.
So this is something I'd thought about prior to, like, for GPU native context as a way to, like, communicate.
You're rather quiet, it's hard to hear you.
It's something I'd thought about, like, prior to for GPU native context as a way for a user mode driver in the guest to talk to a kernel mode driver in the host. It ended up not quite being a good fit for that because of things like handle translation. So, but there were some ideas bouncing around for like a DRM U-ring. I don't remember exactly all the reasons why we landed on IO-ring, U-ring not being a perfect fit, but I think part of it was we wanted a separate ring buffer per queue. So like ring buffers would map more directly to, say, like DRM scheduler instead of one ring buffer per process.
So they were trying to put the actual job in the ring rather than a description of where the job is, where the parameters are, all the other stuff.
Right.
Yeah.
But I mean, the idea is that, like, if you had two threads using two different queues in user space, they could be each writing to their own ring buffer without any locking between them.
Yeah.
Where IOU ring would still require locking in user space for multiple threads accessing the single IOU ring. And the other thing, if we do end up going down this path, that we should try and separate like fencing and basically separate fencing and execution. Like all of the passing of sync objects or DMA fence in and out, bracketing execution of commands could be common code in DRM rather than per driver.
Yeah.
Like for now, like currently in our exec buff and or submit ioctls, there's very very similar DRM sync ioctl parsing in every driver. This would be an opportunity to make that like common between drivers.
Yeah. So my very hand-wavy thought is that when you create a submission for IOU ring, you just create a wrapper around your job or a descriptor around your job. So basically say, here is where the job is, here is the buffers associated with the job, here are the fences associated with the job. And you pass that one into the IOU ring submission queue. The thread goes and reads, does all this stuff, talking to the driver, or there's API in each driver to read that entry and prepare the actual submission. And when they get the response, you just have to add in the completion queue, all you need is just the ID of the submission entry.
Yeah, could be.
And
I think
the rest of the fencing still happens as it happens now. So we're not trying to interpose between the kernel sending the fences and the user space.
Yeah, I mean, it could go either way. I think the idea in the DRM uring context was just that if, like, the submit ioctls coupled all these different things together, because doing multiple ioctls would be worse. So now we have a chance to revisit that. But I think there's some like old GitLab wiki with a bunch of ideas that are bouncing around, that we were bouncing around about this like 3 or 4 years ago.
Yeah, if you stumble over the URL, I'll be happy to have a look. Yeah. So like I said, I haven't wrote one line of code, but if people are interested in being CC'd or I don't know, talk about it, I'm happy to talk. I'll start probably with, because I have the RFC from AMD, it's public. I can start with some AMD devices, and I can start with Mali with Panther devices to do something. I don't know if anyone else is.
I was curious if you have any. Would you expect this to bring down the? It seems like it would bring down the upfront cost of submitting work, but I assume the round trip cost of submitting work and getting completion of the work would still be equivalent to roughly to what it is today, because you still have to do all the same validation and the same kernel level fencing work in the end, but you're just waiting for it later on.
So the current model we have, if you want to, sorry. The current model you have, when you submit a job, you have to basically wait for the job to be finished. There is, at least on the proprietary stack that we have the option to submit multiple jobs where you don't actually care about the result of each of the jobs. There might be compute jobs or something like that you just want them to run, but you don't care about, you're not having any dependencies. So I think that will be helpful. At least in my understanding of the IOU ring, you can batch multiple submissions and then pay the cost after n submissions, or you can do it per each submission. So it'll be I guess the heavy lifting is going to be in the user space on deciding, on the master side, deciding what strategy to use for submitting. When I was talking about the just-in-time thing, you still have to request permissions to be able to use the IOU ring. You need to have the caps, so it's not that freely flowing. You still have to know that, yeah, I want to use IOU ring when I need it.
I guess part of the draw of user space submission to me, though, is not just reducing the serialness of it, but actually reducing the amount of work you need to do in total. I feel like that this doesn't really address that part of it. Yeah,
there's a completely parallel topic about some of the GPUs are now moving stuff into firmware. So what user space does, it's just a setup, and to be honest, the kernel is just a spectator. And a lot of times it gets the interrupt and it needs to figure out what it needs to do with those interrupts. But otherwise, just set up memory, maybe some mailboxes, and gets out. So.
Yeah, I think it still has to handle, I mean, it has to know about how to synchronize things somehow.
Yeah.
But I was just curious how you thought this this proposal interacted with that kind of conversation about those kind of things too.
Yeah, so once we have GPUs that have firmware doing a lot of work, your job submission changes from actually submitting the job to just submitting something for the kernel to do, like VM bind or VM create and all that stuff.
So I think we should pull in, at the very least, we should pull in Alyssa Rosenzweig or Asahi Lena, but she's not here, for Asahi, and we should also pull in Simona Vetter, because to make sure that this could work with DMA fencing rules.
Yeah, I was really hoping that they're here. I guess the switcher didn't help.
I guess I can go out there and try to fetch them, assuming they're out there. Because for context with Asahi, they literally cannot do user space submit ever. The firmware doesn't support it. It assumes its inputs are trusted. So.
Hi.
the reason that the MD proposed a use mode submission is because we have a hardware scheduler. Instead of the the DRM scheduler. So where you have a way to bypass the DRM scheduler for the user mode read. Yeah.
We have a need to figure out a way to bypass. We can see in the future. So Mali GPUs are moving to a future where a lot of the stuff happens in the firmware, not in the hardware. So yes, this is something that we would like to solve as well.
Yeah, and the hardware scheduler actually inside of firmware, they can support multiple reads. And for now, the software scheduler only have a static, the read number inside of the kernel. So that's the different.
Yeah. Welcome to sort of chat and see what we can do about it. So for CMAS, hi. I'm trying to propose some crazy things. Adding IOU ring in DRM at the framework level. Where you put in the submission queue a wrapper around the job that the kernel executes at the moment. And then a K thread starts per FD, per something.
Does it work?
Yeah, you just have to either hold it or.
Yeah, I need to hold it. I think we've been talking about this for years, and no one made it happen. It's kind of, it might make sense for like the memory binding queues, which are like specified in Vulkan to be queues. If you have like user space submit, maybe just a user space submit and ignore the entire U-ring thing. Maybe.
I'm willing to work on it if people tell me I'm not crazy and I should go and do something else.
I think at the framework level, probably the only thing that really makes sense is the memory binding GPU VM stuff that Vulkan needs, which is like a queue engine thingy. That might make sense for IOU ring. For everything else, I would say at the framework level, just leave it up to drivers. If it makes sense in your driver, like run with it. If it doesn't, okay.
Yeah, well, I was basically, because it's just having a K thread that reads from the submission queue once stuff is done, puts the result in the completion queue. I was thinking we can have a submission layer for each GPU, and then GPU driver implements the thing.
Like for actual like hardware submission, my entirely uninformed gut feeling guess would be it probably makes more sense at the driver level and at the framework, and maybe like in DRM schedule you want some support for this, but not like as a DRM API thing.
Yeah, I don't want to decode the job at the framework
level. Exactly,
level.
for this reason. Yeah. So, but for a lot of like the big hardware, it's moving to the user space submit directly, and then you kind of don't need user space submit and the IOU ring at the same time.
Yeah.
So that's like one queue submission thing too much. So for the memory binding thing, I think that's probably something where a lot of drivers might be interested. And the other is like, maybe a bit of code in DRM schedule to make this easier. But honestly, like if you're the first driver, just type it up and like see whether it makes sense for Mesa and all that. And compute and ship it. And when we have a second driver, we can then figure out how to integrate it into DRM schedule with some convenience functions, maybe.
So first, yes, I was suggesting a bit earlier that once you move to GPUs that have a lot of stuff that communicate between user space, this mechanism is only used for stuff that you want the kernel driver to do, like VM bind and all the stuff.
Yeah, exactly. Maybe I shouldn't monopolize the question time here, and we should move to the halfway track and give Daniel Stone some time.
But sure. One last thing. So your second one was about being interested in multiple ones. So I was saying AMD had the public RFC a couple of years ago that had a submission queue, completion queue. So I can have a look at that one and maybe adopt it.
I forgot that they ever did that. I have no idea.
I have a link or somewhere of a thread. You're saying that for
I
the past.
think Christian Hexberg
Okay.
has an IRU ring somewhere.
Probably.
Once, probably.
Sounds about right.
So I was just going to ask what your GitLab. I was just going to ask what your GitLab username was.
Dliviu, DLIVIU.
Okay, well, just find me afterwards.
Okay, yeah, sure.
And the other thing I said earlier before you came in, we should probably try and make some of the fence/syncops handling common, so that we don't need that sort of parsing in every driver, because that kind of sucks right now.
But my gut feeling is to stay out of it at the moment. Like, don't even try to interpose between the fences. But the one thing I would like to talk to you, Sima, is DRM scheduler. I wonder if it's something that we should bypass, actually. We can do it on the
Complicated.
sorry.
Yeah, I think like Seema was saying, it probably mostly makes sense for the stuff like VM bind and, queue create and submit, and just, optimize more for user space submit. When you're talking about an analog to DRM atomic check, the reason we've got that is because atomic is very explicitly, as a design principle, you as a user generically have no idea what might work. And so there's a lot of brute force trial and error, but I'd expect with hardware specific drivers using this that they wouldn't need the same, that, instead of a sort of fairly round trippy, here's a configuration, will it work? Yes, great, I'll use it then. That, did you have anything in particular in mind that you would expect to be a try, fail, iterate pattern? Because otherwise, having that check seems a bit.
No, when I was putting there about DRM atomic check, I was thinking more like about DRM submission check, where basically you validate the sanity of the submission, security, some other protection stuff. I don't really think try and see if it works model is interesting.
Yep.
My assumption at the moment is user space knows what it's doing.
Yep.
It's going, rather than calling an ioctl now, going to the kernel and submitting the stuff,
Yep.
puts it in the queue and does it. You want to protect against bad actors trying to do sneaky thing.
Yeah, that makes sense, but it seems like more of an implementation detail, right? Of if you try to do VA ops, which are so malicious that the kernel's gonna reject them, then I'm not sure how much graceful error handling you need.
You
to
just treat that like a GPU hang.
Sorry?
You just treat that like a GPU hang.
Exactly,
Context
you shoot the context.
So
yes, but that's going to be reflected in the completion queue result, rather than in the check.
That's fine. I mean, you discover GPU crashes asynchronously as well.
Yeah.
So the only return value you ever need is like a fence or a syncops back to user space. Like critical path, everything user space should just do right, or you just...
The IO ring API at the moment doesn't have anything like that. It's basically you put the things in the submission queue, you go and check the completion queue when it's done. You have the option when you submit, like, oh, I'm waiting for these events, and the code is going to do the check for you, but nothing else.
Yeah, I'm not convinced you want to use IOU ring literally as much as a idea or concept.
Yeah. I know it's tempting to duplicate the code. I'm just lazy.